I want to continue our conversation about solving equations, and in this video I would like to classify the types of equations as we solve them. So a conditional equation, and there are three types, you see them below. A conditional equation is an equation that has a solution. Notice it says there's a single or multiple solutions, so the equation is true for one or more variables and false for any other variables. This is what we've been doing all along. So when it comes down to conditional, if you get an answer like x is equal to -5, then that's what we call a conditional equation. So the equation is true as long as x is equal to the solution, the value you found. On the other hand, an identity, we have yet to run into one of those, and we will in this video. Every value is a solution. So every real number is a solution. It says so the equation is true for all values. We'll take a look at what those look like in the middle of the video, but they don't have a solution. So you're going to find out every number is a solution, and you'll see it's an identity. It'll be a true statement at the end. Might as well point that out to you. It looks similar to this, like you might get to a line that says 5 equals to 5, or you might get to a line that says 2x is equal to 2x. Notice it's exactly the same value on both sides, so that is what we call an identity. And then third, we have this thing called a contradiction. Okay, and for a contradiction, there is no solution. You've been given an equation that cannot be solved because there is no value that makes it true, no value whatsoever. So what does that look like when you solve? Well, let me show you. If you get a statement at the end that says 5 equals 6, that's a contradiction, right? That's not a true statement. So what would happen is your variables will cancel out because you may subtract 5x from both sides and they go away, but then you're left with some constant equals another constant that's just completely not true. And then you know there is no solution, which means there is a contradiction. Often contradictions are noted like this, the circle with the line through it, which means it's an empty set. There are no solutions. So let's solve some equations here. I've got a first one here. You see it's huge. Let's work through it. It's extra practice solving, and then when we finish, we will determine, do we have a conditional equation, an identity, or a contradiction based on the definitions I just gave you. So to simplify, right here, if you're looking on the left, notice we want to simplify the left-hand side completely and then separately the right-hand side completely before we even attempt to use our properties of equality to solve. So what I notice on the left, don't add 4 plus 9 is 13. Remember, that's order of operations done incorrectly. You have to multiply first. And to multiply this 9 times 3x minus 7, I must use the distributive property. So I'm going to bring the 4 down plus, now we know 9 times 3x is 27x. We know 9 times -7 is -63. I can continue to simplify on the left-hand side. This 4 right here and the -63 are like terms. So I'm going to write 27x, I just happen to write it first, and then 4 minus 63, or think about it as 4 plus a -63 is going to be -59, so I'll put -59. The left-hand side is completely simplified. Now I'm going to work on the right-hand side. Now again, careful, I can't go ahead and combine this -13 and this plus 23 because there's multiplication here and I must use the distributive property to simplify. So on the right I have -42x minus 13, then I'm just simply recopying. And then I'm going to multiply 23 times 3x, and that's going to give me 69x. And I also have to multiply 23 times -2. And that's going to give me -46. Now, when I combine my like terms together here, and I'll highlight these for you, I have a -42x and a plus 69x. when I add a negative 42 and a plus 69. Remember, you're adding opposite signs, which really means you subtract the numbers. And 69 minus 42 is going to give me 27x. It's positive because the larger of those two is positive. I also have constant-like terms. This negative 13 I can combine with this negative 46. Now, since they're both negative, what I'm actually going to do is add those values together, and that's going to give me a negative, what is that, 59? Okay, so I could write plus a negative 59, or I can just write minus 59. Now, if you'll notice, each side is completely simplified. The left-hand side, I can't combine those because they're not like terms. The right-hand side, I can't combine those either. But take a look what's going on. These are identical, which is screaming identity. This is an identity. Now, what if at this point you really weren't paying attention, that they were exactly the same on both sides, and you just decided to start solving? So remember, a line down through the equals. The first thing I want to do is get all my x's on one side. So to do that, I would need to subtract 27x. Okay, well that cancels and that cancels, and I get a statement that says negative 59 equals negative 59. Remember on the previous page where I showed you with an identity, you get a true statement like 5 equals 5 or 2x equals 2x. That's where we are. So even if you take it further, your variables disappear and you still have a true statement in front of you that says negative 59 equals negative 59, which means that you have an identity, which also means any x you substitute in would work. So every x, you could plug in 0 would work. You could plug in 1, it would work. You could plug in 1,000,000, it would work. Okay, and that's what an identity is. So every single x value substituted in will work. So there's no check in it. If you wanted to check your work, you really would just have to redo the problem, or you could plug in a bunch of x values, but that's more work than you probably want to do. Okay, so question B, same directions. It says solve the equation, so that's always going to be the first step. You've got to solve it before you can realize if it's conditional identity or a contradiction. There are a few you could look at right off the bat and tell, but more than likely that's not going to be the case. So you just start the process of solving, which means you simplify each side separately. Okay, so look at the left-hand side. There's a lot going on here. I have an 11 and then parentheses q plus 3. So that means we need to use the distributive property because this is multiplication. So I have 11 times q, and I also have to do 11 times 3. So 11 times q is 11q, and then when I multiply 11 times 3, we know that's 33, so I'm going to put plus 33 because it's positive. The minus 5 is outside the parentheses, so I just bring that down. And on the right, that is completely simplified. That's just 19. Now I have some like terms here. This 33 and this minus 5, I can go ahead and combine together. Those are both constants. So I have 11q, and then 33 subtract 5 gives me 28, and it's positive. So I put plus 28 equals 19. And then now each side is completely simplified. So I start the solving process. So remember, we draw the line down. And the first thing I want to do is undo addition or subtraction. So I'm adding 28. I want to do the opposite and subtract 28 from both sides of my equation. So notice once on the left of the equals, once on the right. The 28's cancel. So now I have 11q still remaining on the left. And I have 19. And remember the trick, if you're dealing with subtraction, you can just take that as a negative and add instead. So 19 plus a negative 28 is negative 9. Oh, I didn't change my color back, so I meant to leave that red, is negative 9. Okay, and how did I get that? Again, when you add a positive and a negative, you subtract. So 28 minus 19 is 9, but the bigger of the two numbers is negative, so that's why it's negative 9. The last step of solving is to divide by the coefficient. So I'm going to make that coefficient of q1 by dividing by 11 on both sides. So the 11's cancel, and I have my solution of Q is equal to negative 9 over 11. Now that's an answer, which means this is a conditional equation. Okay, so what we have is a conditional equation. Anytime you get an answer, it's conditional. And all conditional equations you can check. So you have 11, and I'm going to substitute in negative 9 over 11 for Q, and add 3, minus 5, and check to see if that really equals 19. Now, I do order of operations, which means I add in first. So this 3 is actually over 1. Now I need a common denominator. That happens to be 11. So what I need to do is I need to multiply my fraction of 3 over 1 times 11 in the denominator and 11 in the numerator, which is going to give me, well, I keep hitting, I think, every button I don't need to hit. I apologize. But that's going to give me 33 over 11. So now I have 11 times negative 9 over 11 plus 33 over 11, and I'm just recopying the remainder. Now I have 11 times negative 9 plus 33 is going to give me 24 over 11, and then minus 5. Does that really equal to 19? Well, how about this? This 11 and this 11 cancel. That helps. 24 minus 5, and 24 minus 5 is 19. So we checked it, and it is correct. But conditional is what we're after there. Anytime you get an answer, it's conditional. Continuing on, look at this huge problem. This is just a lot of practice in using the distributive property and simplifying, isn't it? So on the left, so here's our equal sign right in the middle of the problem. So what I want you to do first is think about this as two separate problems. On the left I need to simplify, and on the right I need to simplify. And I'm just going to start with the left. This is 8 parentheses 1 minus 3x, which means I need the distributive property. So we know 8 times 1 is 8, and then 8 times negative 3x. Go ahead and take that negative with it. Instead of saying minus 3x, think about that as plus a negative 3x. So 8 times negative 3x is negative 24x. So we've handled that. Now this 15, I have to do the same thing. So 15 times 2x is going to be plus 30x. And 15 times 7, might go to my calculator for that one. So 15 times 7 is 105. Now there is an equals in the middle, but let's completely simplify the left-hand side. I've got like terms. I've got a negative 24x and a plus 30x. I can go ahead and combine those together. And when I do, negative 24 plus 30 is 6x. And you know what? I can go ahead and combine together the constants, the 8 and the 105. When I add those together, 8 plus 105 will be plus 113. Now the left side is completely simplified. Let's move over to the right-hand side and do the same thing. And y'all, I'm going to make the right-hand side a different color just so it's not distracting. So 2 times x and 2 times 50. I have to use the distributive property. So that's 2x, and 2 times 50 is 100. And here I have to distribute the 4 inside. So 4 times x is positive 4x, and 4 times 3 is plus 12. And then the plus 1 is on the outside of the parentheses. I just bring that down. Now once again, I have some like terms going on. I have a 2x that I can add to this 4x, and that will result in 6x. And then I have other like terms of constants, 100, 12, and 1. And when I add all those together, I get 113. Look at there. So my red on the left side is 6x plus 113. My blue on the right side is 6x plus 113. You know what that means, right? We have an identity, which means every single x value would work in this big ugly equation we have at the top. Now if you didn't notice it there, your next step would be to subtract 6x from both sides, and you would see that your variables just disappear. and you get a true statement in the end that says 113 equals 113, and again, that tells you it's an identity. When your left and right side match exactly, you know you're dealing with an identity, and again, an identity means any x value plugged in here would work. So if you wanted to plug in x equals 2,000 into every x, you would get a true statement, or if you wanted to plug in x equals 0, you would get a true statement. So we get to practice more of the distributive property. So notice on D, and I'm looking at the left-hand side, what needs to be done? Well, I need to distribute that 5 inside the parentheses. So I have 10C plus, now I have 5 times 5 is 25, and then 5 times C would be plus 5C. Now I do have like terms. I'm going to highlight for you. I have a 10C that I could add to this 5C. And when I do that, I have 15C plus 25, and that's as simple as the left-hand side gets. Okay? Let me move to the right-hand side. So I have to distribute there as well. 3 times 5C is 15C. 3 times negative 4 is minus 12. So that's already combined together. That's 15C minus 12. Now these are not exact, which means I have to continue to solve. So remember, I keep my equals lined up, and I need all my variables on the same side. So to pull that off, I would subtract 15C from both sides of the equation. But look, they completely disappear because it's 15C on both sides. That's a warning that something weird's going to happen. Now you have 25 is equal to negative 12. Now when in your life has 25 ever equaled to negative 12? There's no variable left, right? So since 25 can never equal negative 12, this is what we call a contradiction. And that's what happens when you have contradictions. In the end, you get a statement that says some constant is equal to some other constant, because right here your variables matched and they canceled out. So you're left with 25 equals negative 12, which can't happen. What does that really mean about the problem? It really means that there is no C value that exists that would make the left side equal the right side. It's an impossible equation, okay? Now, how would you answer that? Well, in a lot of online homeworks, you would enter the empty set, okay? Which is just the circle with a line through it. You would find that in a pad that comes with the program. So you would just select some palette that has that. One more comment, no solution is another valid answer for this. Now, no solution is not really valid the way I asked it. The way I asked it is, say, is it conditional, an identity, or a contradiction? And it's a contradiction. We answered the question. But if you were solving the equation, no solution would be appropriate, or the empty set would be appropriate as well. Okay, I have one more. This is the last problem I want to do in this video. Same directions as is throughout. We want to solve the equation, and when we're finished, we want to classify it as conditional, an identity, or a contradiction. And so the first step in solving any equation is to simplify each side completely first. And I noticed this left-hand side, we can distribute. Now, again, it still may be your tendency to want to add 6 plus 14. You can't do that because multiplication, remember this is multiplication, comes before addition. So I have to distribute the 14 inside. So this gives me 6 plus, and then 14 times k is 14k, and then 14 times negative 8, I'll do that in my calculator. I think I will. There we go. Is minus 112, and the other side is simplified at 13. Now I have like terms, they are just constants. So this 6 and this negative 12 we can combine together. So that's 6 plus a negative 112, which would be negative 106. So this is 14k, and I'm just going to write minus 106 because it's negative 106 equals 13. Now it's just to solve for k, so I'm going to add 106 to both sides of my equation. Remember, draw the line down your equals so it's on each side. Those cancel. I get 14k is equal to, now 13 plus 106 is 119. And then I divide both sides by 14. So k is equal to, now I don't believe 119 divides by 14. It doesn't, but it does reduce. So I know 2 doesn't go into both of them. 2 goes into 14, but not into 119. What else divides into 14? Well, 7. So let's make sure that 119 doesn't divide by 7. It does. So that would be 17, and 14 divided by 7 is 2. That is the completely simplified version. So I divided each of these, by 7. There we go. Now, which is it? Is it conditional identity or contradiction? Well, if you get a result, if you get an answer, that means it's conditional. Okay, so our answer is k equals 17 over 2, and this is a conditional equation. We could check it. Then I'm going to save you the grief of checking it, but you would know what to do. Plug 17 over 2 back into k, and check it out. And you will get that 13 equals 13, and you'll know it's right. Hope you have a wonderful day.